All right, this is Unit 5, Lesson 3. We are going to be writing linear inequalities. All right, so let's just review what the inequality symbols are. This is less than, greater than, less than or equal to, greater than or equal to. And so what we're going to do here is we're going to identify these words and what they mean as it pertains to the inequality symbol. Okay, so we say something that is, we have at most 10 people can come, then that is less than or equal to. Okay, that is means at most 15 means you could have 15 or anything less than that. At least is greater than or equal to. No more than is less than. No less than is greater than. Greater than is greater than. Less than is less than. Fewer than is less than. More than is greater than. And less than, I think that's a repeat. My bad. All right. So that's what that means. There are no more than is less than or equal to. And no less than is greater than or equal to. Okay? So you've got 4 here that are less than or equal to, greater than or equal to, and then you've got these down here that are without the equal to. And this is not the only words that you may see, but those are the most popular. So when you see those words, you need to know what symbol to write. All right, so when we're writing linear inequalities, the first thing we want to do is identify the variables in the problem. The variables represent the unknown. The inequality may or may not be in slope-intercept form. Remember, it can always be rewritten. So we may have something that looks like this, okay? And if we're trying to graph that, we could put the y by itself and graph it that way, okay? All right, but the first thing we want to do is identify the variables. What is unknown? So Beverly is serving hamburgers and hot dogs at her cookout. Hamburger meat costs $3 per pound and hot dogs cost $2 per pound. She wants to spend no more than $30. Write an inequality to model the situation. All right, so what do I not know? Or what do I do know? I do know that the hamburger is $3 per pound. I know the hot dogs is $2 per pound. But I don't know how many pounds that she's cooking or buying. Okay, so that's going to be my variable. So I'm just going to use X and Y. So X is going to be the pounds of hamburger, and Y is going to be the pounds of hot dog. So now that I know that X represents the number of pounds of hamburger and Y represents the number of pounds of hot dog, I can write an equation or an inequality to model the situation. All right, well, it says $3 per pound for hamburger. So we're going to multiply X times 3. And she's buying hot dogs, which is $2 per pound. Notice I'm putting the right variable next to the right number. And that needs to be no more than $30. So that's going to be less than or equal to 30. No more than. Okay, remember we did that up here. No more than is less than or equal to. All right, so there's my inequality. Now I need to graph it. Well, there's 2 ways that you could graph this. This is in standard form, if you remember. What is standard form? Standard form is ax plus by equals c. So this is A, B, and C. So if I know that this is standard form, I could find the x and y intercepts using the cover-up method. Okay, so let's do that. So the x-intercept, if I cover up the y, is going to be 10. So I know that I have the point 10, 0. And my y-intercept is going to be 15. So I know I have the point 0, 15. How did I get that? I just cover this up. 30 divided by 3 is 10. Cover this up. 30 divided by 2 is 15. All right? Now, you have to remember that we have this less than or equal to symbol. Okay, so when we graph it, we have to know what kind of line we're using and where we're going to shade. So I'm going to go ahead and plot this point 10, 0. Now 0, 15 does not fit on my graph, so that's not going to really work. All right, so let's look at it a different way. So I'm going to write this again. 3x plus 2y is less than or equal to 30. All right, so we're going to solve for y. So we can get the slope. Well, we already know the y-intercept, but we need the slope. Okay, so I'm going to subtract 3x, subtract 3x. So now 2y is less than or equal to 30 minus 3x divide by 2. So y is less than or equal to 15 minus 3 over 2x. So what is my slope? My slope is negative 3 over 2. Okay, remember this is my y-intercept. This is my slope. So if that's my slope, then that means the line's going down like that. Okay, so if I have this point, what can I do? Okay, I can go down 3 over 2, but that's not going to help me. So I need to go up 3 and over 2 this way. So 1, 2, 3 over 2. So I have a point here. 1, 2, 3 over 2. All right, that's really as far as I'm going to get. Okay, so now I need to make a line. Well, what kind of line am I going to make? According to this, I'm going to make a solid line. All right. Let's see. Here we go. All right. All right, so it's going to be a solid line. Now, where are we going to shade? All right, we're going to shade on the less than. So we are going to shade on this side. So this is the area that represents all of the solutions. Now, if we think about this, it's talking about hamburgers and hot dogs, and she doesn't want to spend more than $30. Okay, so X, what is X? X is the pounds of hamburger meat. Okay, so on this axis is the pounds of hamburger meat. I'll write that here. And just write hamburger. And on the y-axis is hot dog. Okay, so are we going to sell or buy negative hamburgers? No, we are not. Are we going to sell or buy negative hot dogs? No. So the only quadrant that is actually really what we're concerned with is quadrant 1. That is the only quadrant that we are concerned with. So anything in here underneath this black line is a possible solution. So what does that mean? Well, I could sell 1, 2, 3. I could sell 4 hamburgers and 1 hot dog, or buy rather. I could buy 4 hamburgers and 1 hot dog. I could buy 7 hamburgers and 3 hot dogs. Okay? But I cannot buy 8 hamburgers and 4 hot dogs. Okay, this point here represents 8 hamburgers and 4 hot dogs. That is not a solution. So she cannot buy that much. She will be over her budget. All right, let's look at the next one. Sarah can spend at most. What's at most? At most is less than or equal to $7.50 on vegetables for a party. Broccoli, that's a vegetable, costs $1.25 per bunch, and carrots cost 75 cents per package. Okay, so she's got 2 vegetables here, broccoli and carrots, and she wants to spend less than or equal to $7.50. So what are our 2 variables? X and Y. We're going to say X is broccoli. Okay, we're buying that per bunch. And then Y is going to be our carrots. All right, so broccoli is $1.25. So 125X plus 0.75Y needs to be less than or equal to 750. All right. So again, I could try to find the intercepts and graph it that way. All right. But I'm going to go ahead and I'm going to do it from standard to slope intercept. So I'm going to subtract 1.25x. Now remember, the slope, if it's in standard form, the slope's going to be negative a over b. So we should expect that. All right, and then I'm going to divide by 0.75. We should be used to this by now. So y is less than or equal to, because I did not divide by a negative. So this sign does not flip. 750 divided by 0.75 is 10. And then negative 125 divided by 0.75 is negative, hold please, divided by 0.75. Oh, come on. Okay. It is negative, let's see, 1 and 2 thirds, 5 thirds. Oh, sorry, and this was the x. All right, so 10 minus 5 thirds x. All right, so that means my y-intercept is 10, and I'm going to go down 5 over 3. Okay, well, that's kind of a problem because I don't see 10 on the graph. Okay, so I'm going to sort of 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so here's 10. I'm just going to pretend. And I'm going to go down 5 over 3. Down 1, 2, 3, 4, 5. So I should be at 5 now. Over 3. 1, 2, 3. Down 5. 1, 2, 3, 4, 5. Over 3. Down 5 to, let's see, 1, 2, 3, 4, 5. Over 3. All right, what kind of line do I need? I need a solid line. Solid line, and I'm shading below. So these are the solutions. Now again, you have to consider this is a real world problem. So what is actually applicable? What is realistic? Well, what is our x? Our x is the number of broccoli bunches. Our y is the number of carrots. Again, this quadrant, and this quadrant are not applicable. Only quadrant 1 is going to be applicable. Okay, we do not want to deal with any negative numbers. So that is how you write inequalities from word problems. We'll be doing some practice in class, so go back and review any of the video that maybe didn't make sense, and be ready to ask questions in class. See you then.